Hello, good morning everyone. Our topic for today is all about adiabatic process. So by definition, adiabatic process is a constant entropy process. Okay? So start muna tayo sa kanyang PV and TS diagram. So ganito yung itsura ng kanyang PV diagram. So from point 1 to point 2. So ang example natin dito, bumaba ang kanyang pressure mula point 1 hanggang point 2. Okay? Then, when it comes to TS, kung mapapansin natin, ganun din, no? The temperature is directly proportional to the pressure. Kung bumaba yan, edi bababa din sa ating TS diagram. So, mataas sa point 1, bumaba sa point 2. So, kung mapapansin nyo, wala tayong area under the TS diagram. So, kung wala tayong area dyan, ibig sabihin, wala tayong heat na mapoproduce. So, kapag adiabatic process, wala tayong heat transfer. Okay? So, doon na tayo sa formulas. So, start muna tayo sa work non-flow. So, sabi ko nga kanina, di ba? Heat is equals to 0 kasi adiabatic siya. Where work non-flow is equals to heat minus delta U. Since heat is equals to 0, work non-flow is equals to negative delta U. Work steady flow. So, same lang din ang formula natin sa isothermal. Work steady flow is Q minus delta KE minus delta PE minus delta H. So, since Q is equals to 0, therefore, work steady flow is negative delta KE minus delta PE minus delta H. Of course, heat transferred is equals to 0. Then, since constant entropy nga tayo, delta S then is equals to 0. Then sa adiabatic process, meron tayong tinatawag na efficiency of the process. So kapag sinabi natin efficiency, it is equals to the actual work divided by the ideal work. Or ang unit or ang symbol natin is kapag actual, merong prime tayong nilalagay. Then kapag ideal, work steady flow lang na symbol. Okay, so derive natin yung formula. So, in-neglect natin yung delta PE and delta KE. So, ito yung formula ng work steady flow natin. So, kapag ni-neglect natin yan, ang matitira na lang ay negative delta H. Therefore, work steady flow ideal is equals to negative delta H or negative H2 minus H1. So, i-distribute natin yung negative sign doon sa loob. Yan. Okay? So, work steady flow is equals to H1 minus H2. Kapag actual, work steady flow prime is equals to H1 minus H2 prime. Okay? So, ganun. Therefore, kapag sinubstitute natin yung work steady flow prime and work steady flow dito sa efficiency, ang formula ng efficiency natin is H1 minus H2 prime over H1 minus H2. So, yan lahat ng formula na kailangan natin for adiabatic process. So, start tayo with problem number 1. 1 kilogram of steam expand isentropically from 2.1 megapascal and 374 degrees Celsius to 93 degrees Celsius. Find the final quality and the work for non-flow and steady flow processes. Okay, kunin natin si given. Meron tayong mass of 1 kg, P1 of 2.1 megapascal, and T1 of 374 degrees Celsius. Then meron tayong T2 of 93 degrees Celsius. Ang hinahanap is yung quality natin at 2, work non-flow, and the work steady flow. So, solution, kunin muna natin yung properties at T1 and T1. Check natin kung superheated, subcooled, or saturated siya. Okay, so at 2.1 megapascal, kunin natin yung kanyang Tsat at table 2. So Tsat niyan is 214.90. Therefore, T given is greater than Tsat, it is superheated. Okay, so kapag superheated, sa table 3 tayo titingin. So, at table 3, P1 is 2.1 megapascal and 374 degrees Celsius. So, 2.1 megapascal, may eksakto yan eh. Ang walang eksakto lang dyan is yung T1, which is 374 degrees Celsius. So, ang 374, napapagitnaan siya ng 370 and 380 degrees Celsius. So, kunin na natin ang properties at 2.1 megapascal and 370 degrees Celsius. Ang U dyan is 2.7, H is 3179.5, and S is 7.0017. At 380 degrees Celsius, U is 2909.8, H is 3201.7, and S is 7.0360. Okay, so by interpolation, kunin natin si U1. So mode 3 lagay lang natin 370 tsaka 380. So 2892.7, 2909.8. Sorry. Yeah. Press AC, shift 1, 55. Lagay natin 374. Therefore, U1 is 2899.54 kilojoules per kilogram. Solving for H1, punta tayo sa data. Lagay natin si 3179. Then 3201.7. Press AC, shift 1, 5, 5. Lagay natin si temperature, 374. Therefore, H1 is 3188.38 kilojoules per kilogram. Then last is yung S1. Punta lang tayo sa data, edit natin si Y. 7.0017 and 7.0360. Press AC, shift 1, 55. Lagay natin si temperature, 374. Therefore, S1 is 7.0154 kilojoules per kilogram. Okay. Since adiabatic process tayo or constant entropy, yung ating S1 ay automatic equals yan sa S2. So, it is equals to 7.01542. So, yung S2 natin, yan yung gagamitin natin para makuha yung properties at S2 and T2. Okay, at 93 degrees Celsius, ang SG natin dyan is 7.4409. So, therefore, SG is greater than S2. Therefore, saturated yung ating given sa condition 2. So, kapag saturated, titingin tayo sa table 1 at 93 degrees Celsius. So, kunin natin yung ating HF, HG, SF, SG, UF, and UG. So, at 93 degrees Celsius, HF is 389.54 kilojoules per kilogram. HG is 2,664.9 kilojoules per kilogram. SF is 1.2271 kilojoules per kilogram. SG is 7.4409 kilojoules per kilogram. UF is 389.46 kilojoules per kilogram. Then UG is 2498.2 kilojoules per kilogram. So, interpolate na natin by using the entropy and the temperature. Okay? Or the properties given na nakuha natin kanina. So, solve muna natin si H2. Punta tayo sa mode 3 to 1.2271. Then 7.4409. $389.54. Then 2664.9. Press AC. Shift 1, 5, 5. Lagyan natin si delta Y, which is 7.01, 542. So, H2 is 2,509.098 kilojoules per kilogram. Solving for X2, punta lang tayo sa data. Edit natin si Y. So, kapag F, ang X natin is 0. Kapag Y, yung G natin, kapag F, ang X natin is 0. Kapag G, ang X natin is 1. Press AC, Shift 1. Shift 1, 5, 5. Lagyan natin si entropy, which is 7.01542. Therefore, X2 is 0.93153 or 93.15%. Okay, so last is the U2. Punta lang tayo sa data. Edit natin si Y. So, UF is 389.46. Then UG is 2498.2. Press AC, Shift 1, 5, 5. Lagyan natin si S, which is 7.01542. Therefore, U2 is 2353.807 kilojoules per kilogram. So, nakuha na natin yung properties. Solve na natin yung required sa problem. First condition is X2. Nakuha na natin yan, no? 93.5%. Next is work non-flow. So, work non-flow is equals to, since may mass tayo, gamitin natin M delta U or negative M delta U. Okay? So, mass natin is 1 kilogram. U2 natin is 2353.807 and U1 natin is 2899.54. So, magiging positive yan kasi mas malaki yung ating U1 kaysa sa U2. Therefore, work non-flow is 545.733 kilojoules. Work steady flow is equals to the negative delta KE minus delta PE minus delta H. But since wala tayong delta KE and wala tayong delta PE, therefore, work steady flow is negative M H2 minus H1. Substitute natin. So, M is 1 kilogram, H2 is 2509.098, then H1 is 3188.38 kilojoules per kilogram, cancel si kilogram. Therefore, work steady flow is 679.282 kilojoules. So, that's it for problem number 1. Doon na tayo sa problem number 2. Steam flows isentropically through a nozzle from 1,500 kilopascal, 288 degrees Celsius to 960 kilopascal for 454 grams per second. Determine T2, delta B, work steady flow, and delta K. Okay, so kunin muna natin si given. So meron tayong P1 of 15 kilopascal, T1 of 288 degrees Celsius, mass of 0.454 gram per second, and P2 of 960 kilopascal. So ang required natin is T2, delta V, work steady flow, and delta KE. Okay. So kapag sinabi nating nozzle, wala tayong work na nakikreate. Okay? Kapag nozzle. So, kunin muna natin yung properties at 1.5 megapascal. So, at P1. So, di ba equals yan sa 1.5 megapascal? i-divide mo lang siya ng 1,000 para maging megapascal. Okay, so at 1.5 megapascal, Tsat natin is 198.32 degrees Celsius. So mas malaki si given kaysa sa Tsat, mas malaki yung 288 kaysa sa 198. Therefore, condition 1 is a superheated steam. Since superheated siya, sa table 3 tayo titingin. So at table 3, P1 and T1 is equals to 1.5 megapascal and 288 degrees Celsius. So 1.5 megapascal, may eksakto yan sa ating table 3. 288 lang ang wala. So, ang 288 ay napapagitnaan ng 280 and 290 sa table 3. Kunin muna natin yung properties at 280. V natin dyan is 0.16271. U is 2,748.6. H is 2,992.7. And S is 6.8381. At 290 degrees Celsius, V natin is 0.16621. U is 2765.9, H is 3015.3, and S is 6.8785. So, by using interpolation, interpolate natin, kunin natin si H1, S1, V1, and U1. Mode 3, 2 ulit. 0.16271. 0.16621. That pala dito natin nilagay. Temperature muna pala, 280 tsaka 290. Para Y na lang i-edit natin. Shift 155. Lagay natin si temperature to 88. Therefore, V1 is 0.16551. Cubic meters per kilogram. So, kunin natin si ating U1. Ito lang tayo sa data. Edit natin si Y. 2748.6. Then 2765.9. Lagay natin 288. Therefore, U1 is 2,762.44 kilojoules per kilogram. Solving for H1, lagay natin 2992.7. Then 3015.3. Therefore, H1 is 3010.78, and last, solving for S1. Edit natin ulit si Y, 6.8381, 6.8785. Shift 155, 288, ano. Therefore, S1 is 6.8742 kilojoules per kilogram. Okay, so okay na yung properties natin sa condition 1. Ganon ulit, yung S1 natin ay equal sa S2 since isentropic tayo or adiabatic process. So S1 is equals to S2 is equals to 6.87042. Then yung S2 mo, yun yung gagamitin mo para ma-determine mo kung ang iyong condition 2 ba ay superheated, saturated, or subcooled. Okay. So, at 0.96 megapascal, kunin natin yung SF and ST. SF dyan is 2.1215 kilojoules per kilogram. SG is 6.6005 kilojoules per kilogram. Therefore, S2 is greater than SG. The condition is superheated. So, since superheated, ayun, sa ano tayo titingin? Table 3 ulit. Ano? So, table 3 at P2 is equals to 0.96 megapascal. And S2 is equals to 6.887042 kilojoules per kilogram Kelvin. Kunin natin si, ano ba kailangan? Entropy, temperature, specific volume, specific internal energy, and specific enthalpy. So, yung 0.96, may eksakto yan sa ating steam table. So, bali, itong 887042, ano? Tama pala. Ito pala yung mali. 6.8704. So, at 0.96 megapascal, hanapin mo ngayon yung saan napapagit na yung ating entropy 2 na 6.8742. So, titingin ka sa entropy. So, in between siya ng 6.8589 and 6.9030. Okay? So, kunin natin yung ating properties at 6.8589 na entropy. Ang temperature dyan is 230. Specific volume is 0.2319. Specific internal energy is 2,676.9 and the specific enthalpy is 2,899.6. At entropy natin, 6.9030. Ang temperature dyan is 240. Specific volume is 0.2374. Specific internal energy is 2694.1 and specific enthalpy is 2922.0. Okay, so mode 3 to. Solve na natin si T2, V2, U2, and H2. So, lagay lang natin si ating entropy. Lagay natin si temperature na 230 and 240. Press AC, shift 1, 55. Lagay natin si 6.8704. Yun. 232.612 degrees Celsius. Yung 6.87042, store na lang natin sa A, ano? Para hindi na tayo magta-type pa isa-isa. Okay? So, shift, punta tayo sa data, edit natin si B, 0.2319 and 0.2374. Press AC, shift 1, 55. Lagay natin sa A kasi yung 6.87042 nasa A natin. Kaya A na lang ilagay natin. Okay? So, the answer is 0.2333 cubic meters per kilogram. Punta ulit tayo sa data. Edit natin si Y. Kunin natin si U2, 2676.9 and 2694.1. Lagay natin si alpha A. So, therefore, U2 is 2681.393 kilojoules per kilogram. Then, last solving for H2. Press AC ulit. Shift 1.5. Shift data pala. 2899.6. 2922. Kunin natin si H2. Therefore, H2 is 2905.451 kilojoules per kilogram. So, okay na yung ating properties. Solve na natin yung required sa problem. Okay, so, first na required is T2. Nakuha natin si T2, no? T2 is equals to 232.612 degrees Celsius. Next is delta V. So delta B is MB2 minus P1. So mass natin is 0.454 kg per second, V2 is 0.2333, then V1 is 0.16551. So cancel natin si kilogram, therefore delta V is 0.031 cubic meters per second. Then work steady flow. So sinabi ko nga kanina, di ba, kapag nozzle, wala tayong work na napoproduce. Therefore, work steady flow is equals to 0. Then delta KE, kunin natin sa formula ng work steady flow. So work steady flow is equals to negative delta KE minus delta PE minus delta H. So nozzle tayo, wala tayong work steady flow and wala tayo delta PE. Therefore, delta KE is equals to negative delta H. So yung negative delta KE, nilipat lang natin sa kabilang side of the equation. Therefore, delta KE is equals to negative mH2 minus H1. So meron tayong mass, 0.454 kg per second. H2 is 2,905.451 and H1 is 3,010.78. So cancel si kilogram. Therefore, delta KE is equals to 47.819 kilowatts or kilojoules per second. So, yun na sa ating problem number 2. Then last problem tayo, problem number 3. Number 3, a steam turbine receives 0.52 of steam at 300 degrees Celsius. Then expand in an irreversible adiabatic process to a pressure of 0.012 megapascal. If the exhaust steam is dry and saturated, calculate the work of an irreversible process and the efficiency of the process. So medyo kakaiba na itong problem number 3 natin kasi hinahanap na yung work ng irreversible process and the efficiency of the process, unlike dun sa mga previous problem natin sa processes. So kalimitan kinukuha is heat, delta H, delta U, delta S. Ngayon iba naman na. Yung hinahanap na is work of irreversible process and the efficiency of the process. Okay, so kunin muna natin si given P1 and P1 is equals to 0.52 and 300 degrees Celsius respectively. P2 is equals to 0.012 megapascal. So sinabi dyan na yung exhaust natin or condition 2 is dry and saturated. So ang hinahanap is the work steady flow and the efficiency. So solution, so discuss muna natin what is the difference between reversible and irreversible process. So kapag sinabi natin reversible is one in which both system and the surroundings are returned to their original state. So kapag reversible, bumabalik or cycle yan, bumabalik siya sa kanyang original state. Unlike kapag irreversible, hindi na siya bumabalik sa kanyang original state. So, yun yung pagkakaiba ng dalawa. Okay? So, kunin muna natin yung properties natin at P1 and T1. So, at P1, 0.52 megapascal, ang Tsat natin is 153.34 degrees Celsius. Therefore, P1 and T1 is a superheated condition. So, kapag superheated, sa table 3 tayo titingnan. So, by using P1 and T1, 0.52 megapascal and 300 degrees Celsius. So, good thing nga lang may eksaktong 0.52 and 300 degrees Celsius sa table 3. So, direct reading lang. U1 natin is 2802.6, H1 is 3063.7, and S1 is 7.4411 kilojoules per kilogram. Then, same process, S1 is equals to S2, which is equals to 7.4411 kilojoules per kilogram Kelvin. Okay, so when it comes to solving H2 prime, kasi nga, di ba kailangan natin ng ating efficiency, tingnan natin siya sa ating TS diagram. So, actually, di ba pag TS diagram, kapag ideal, from point 1 to point 2, straight line lang siya. Di ba? But since due to irreversibility, di ba? Magkakaroon siya or yung sa actual natin, yung 2' natin, nandito, dry and saturated. Ayun yung sinabi dyan. So therefore, meron kang work steady flow actual na mapoproduce. Okay? So iba yung work steady flow actual mo sa iyong work steady flow ideal. Okay? So di ba ang work steady flow actual is H1 minus H2 prime. Okay? So ayan yan. So para makuha natin si H2 prime, since dry and saturated naman yung ating condition at actual or 2', therefore, nasa ano yan, di ba? Nasa G. Then F. Therefore, H2' is Hg at P2. Okay? So, ano yung Hg natin at 0.012 megapascal? So, from table 2, H2' is 2591.1 kilojoules per kilogram. So, okay na tayo sa H2'. And meron na rin tayong H1, makukuha na natin si work steady flow prime. So, solving for work steady flow prime, it is equals to H1 minus H2 prime. Sa H1 nakuha natin, 3063.7. H2 prime is 2591.1 kilojoules per kilogram. Therefore, work steady flow prime is 472.6 kilojoules per kilogram. Now, solving for efficiency. Efficiency is work steady flow prime divided by work steady flow. So, meron na tayong work steady flow prime. Kulang na lang natin si H2. Kasi meron na rin naman tayong H1. So, para makuha natin sa H2, so mode 32 at 0.012 MPa. So, gagamitin natin si S1 is equals to S2. So, doon natin kukunin si H2. Okay? So, at table 2, 0.012 MPa, kunin natin si SF and SG. So, ang SF natin dyan is 0.6963. Ang SG natin is 8.0863. Then, HF natin is 206.92. Then, HG is 2591.1. So, interpolate natin, mode 32, 0.6963. And 8.0863. 206.92. 2591.1. So, ilagay lang natin si entropy 1 is equals to entropy 2, 7.4411. Therefore, H2 is 2382.944 kilojoules per kilogram. So, okay na yung H2 natin. Direct sub na lang sa efficiency. Therefore, efficiency is 472.6 kilojoules per kilogram. H1 is 3063.7 and H2 is 2382.944. Kung mapapansin nyo, si H2 is less than H1, is less than H2 prime. Diba? 23 yan. 2382. Yung H2 prime natin is 2591. Kasi kung mapapansin nyo dito sa graph, no? Mas malaki talaga si 2 prime kaysa sa 2. Mas malaki si actual kaysa sa idea. So, tama yung ginawa natin. Okay? Ganon lagi. So, ayun na. Therefore, and efficiency is 69.423%. So, that's all for our lecture. So, kung may question, paki-message na lang sa group natin. So, stay safe and thank you.